just how far we've gotten. Oh. Okay. Okay. Hello, class. Can you hear me? I can't hear them. Okay. Okay, louder. Okay, today we are looking at congruent triangles. You will learn to identify the parts of triangles and to classify triangles by their parts. In geometry, a triangle is formed when three non-collinear points are connected by segments. So this picture that you have that I'm pointing at is a triangle. Each of these segments are connected at these points, E, D, and F. Together they form a triangle. The vertex of each angle is a vertex of the triangle. So right here, this F, this D, and this E are the vertexes of the triangle. Triangles are named by their vertices. So triangle DEF is written as a triangle, then the letters D, E, and F, because as you can see in this triangle, the vertices are with the letters D, E, and F. So you would write it D, E, F. If the D, E, F was an A, B, C, you would just write it as a triangle A, B, C. Put on this pen. So if that was an A, and this E was a B, and this was a C, you would just write that as triangle A, B, C. The way that you write it is based off of what the vertexes are called. Oh, whoa. So the sides are also classified by what the vertex is assigned as. So one side is EF. It is from the vertex E to the vertex F. It has a line over the top, EF. This side is FD with a line over the top, and the last side is DE with a line over the top. The vertices again are D, E, and F, and the angles are angle E right there, angle F right there, angle D right here, and they have this little, kind of looks like a little L. That means it's an angle. So in chapter 3, I assume you were told about the different kinds of angles. You can have acute, obtuse, or right angles. That is also how we classify triangles. All triangles have at least two acute angles, which you will remember means that the angle is less than 90 degrees. So all of these three are, or D and E are acute angles. They are less than 90 degrees, and then F would be an obtuse. The third angle is either an acute angle, an obtuse angle, or a right angle. And then based off whether it has three acute angles, two acute angles, and an obtuse angle, or two acute angles and a right angle, is how you know whether it is a acute triangle, an obtuse triangle, or a right triangle. So right here, we can see that this angle is 40 degrees. This angle is 80 degrees. This angle is 60 degrees. It's an acute angle because it's acute triangle because all three angles are acute. This 40 makes it an acute angle. The second is an obtuse triangle because the top angle right here is a 17 degrees. The bottom angle is 43 degrees. This angle is 120 degrees. If it is greater than 90 degrees, the angle is obtuse and the triangle is obtuse. The third example is a right triangle because the top angle is 30 degrees. This bottom right angle is 60 degrees. The bottom left is 90 degrees. Whenever you see this little square on an angle, that means that it is a right angle, which equals 90 degrees. So this equals slower talk. Okay. 90. So whenever you see that on a triangle, the one that I'm drawing right here, it always means 90 degrees. And that makes it a right angle and a right triangle. Now, the three types of triangles: scalene, isosceles, and equilateral. A scalene triangle has no congruent sides. What that means is that all three sides are different lengths. So scalene triangle, no congruent sides, all different lengths. An isosceles triangle has two congruent sides, at least two congruent sides. And the equilateral triangle has all three congruent sides. The angle formed by the congruent sides is called the vertex angle. The congruent sides are called legs. So these are, these are both legs right on the sides. And then the two angles formed by the base, which is the bottom of the triangle, this line that I'm pointing at is the base, and they're called the base angles. So these two, here we go. So these two angles right here are the base angles. Uh-oh. And that, what is... Whoa. Don't click the pen. Okay. I didn't mean to, my thumb just kind of hit it. Now it's just going wild.
Don't worry. Where's your keyboard? Oh, you just put it over there? Okay, well, I'll have it for you.
Now be placed into the context.
Okay.
You can use the pen, but just don't click the...
Avoid clicking.
Avoid clicking, you'll be fine.
Okay.
Yes, exactly.
Okay, so we are back. So these angles at the bottom that are formed between the two legs and the base are called base angles. This top angle is called a vertex angle. Oh, end of section 1. Okay, the angle sum theorem. On a piece of paper, draw a triangle. Place a dot close to the center or interior of a triangle. After marking all of the angles, just like I did on the last triangle, tear the triangle into 3 pieces. Then rotate them, laying the marked angles next to each other. Make a conjecture about the sum of the angle measures of the triangle.
I'm sorry. Let me take care of it.
Are they not on?
No, this it automatically linked to whoever gets it except me. So you have to. Okay, they should be over here now.
Oh, could they not hear me?
Well, for like a minute because you locked out.
Ah.
Automatically mute everyone who enters later.
Okay.
You can't have 40 students talking at the same time.
Then it's like a real school. Okay. Angle sum theorem. On a piece of paper, draw a triangle. Place a dot close to the center or interior of the triangle, right there. After marking all of the angles, put a little line by all 3 of the angles of triangle. Tear the triangle into 3 pieces. Then rotate them, laying the marked angles next to each other. Make a conjecture about the sum of the angle measures. If you conjectured that they all equaled 180 degrees, you were correct. In a triangle, all 3 angles added together equal 180 degrees. So x plus y plus z will always equal 180 degrees in a triangle. No matter if it's a right triangle, scalene triangle, isosceles, acute, obtuse, will always equal 180 degrees in a triangle. The acute angles of a right triangle are complementary. So x plus y equals 90. Because we know that this little square always equals 90 degrees. We know a triangle always equals 180 degrees. So x plus y have to equal 90 degrees. They have to equal 90. The measure of each angle of an equiangular triangle is 60. All 3 angles equal each other, so it is 3x. X times x times x. It's not x times x. It's x plus x, or 3 multiplied by x. And since we know that all triangles equal 180 degrees, we know x must equal 60 in an equiangular triangle. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. These red lines at the angles show you that they are all equal. Okay. Translations, reflections, and rotations. In geometry, there are 3 fundamental types of motion: translation, reflection, rotation. In translation, you slide a figure from one position to another without turning it. Translations are sometimes called slides. All you do in a translation is move the figure. You would move the triangle without changing any dimensions or sizes. You're just moving it. So from point A to point B. That is a translation. A reflection, you flip the image over a line. The new figure is a mirror image of the old figure. Reflections are sometimes called flips. So you pretend that there's a line of reflection right down the middle, and in a reflection you completely draw the mirror image of the original image. So this angle is moved all the way across to that angle, this angle to that angle, this angle to that angle. In a rotation, you rotate a figure around a fixed point. Rotations are sometimes called turns. So if this is your figure and this is your fixed point, you would just rotate the figure. Right here we have this being the fixed point, and you are just rotating it this way, 30 degrees. So in a recap, in translation, you slide the figure without changing any dimensions or sizes. In a reflection, you flip the figure over a line, showing the mirror image. And in a rotation, you turn the image around a fixed point. Each point on the original figure is called a pre-image. So on this triangle, ABC, A is the pre-image. Its matching point on the corresponding figure is called its image. So A is the pre-image, D is the image. B is the image, pre-image, sorry, B is the pre-image, E is the image, C is the pre-image, F is the image. So this is the translation that we're seeing right here, and all we do, we're moving a triangle down. The pre-image is A, the image is D. B just slides down, no sizes are changed, no dimensions are changed. We're just sliding the triangle. Each point on the pre-image can be paired with exactly 1 point on its image. And each point on the image can be paired with exactly 1 point on its pre-image. This one-to-one correspondence is an example of a mapping. So A only corresponds to D, B only corresponds to E, and C only corresponds to F. The symbol of an arrow, we see right here, is used to indicate a mapping. So these arrows that we see indicate a mapping. In the figure triangle ABC to triangle DEF, it's saying triangle ABC maps to triangle DEF. No sizes are changed, no dimensions are changed. The points slide down. Mapping. In naming the triangles, the order of the vertices indicates the corresponding points. So A is at the top of this triangle, C and B are its bases, D is still the top of the new triangle with F and E as the bases. These are corresponding to each other. Right here we see A maps to D, B maps to E, and C maps to F. The same picture as we've been seeing of this triangle transitioning down. we also see that the lines are being mapped. So the line AB slides down and is the same as the line DE. That's that. Line BC, the base, slides and becomes EF. See that right there? And then line CA slides and becomes FD. We're not rotating the image, we're not changing the size, we are just sliding it down. It is the exact same image, now in different coordinates. This mapping is called a transformation. Translations, reflections, and rotations are all isometries. An isometry is a movement that does not change the size or shape of the figure being moved. So as we see in these triangles, neither the size nor the shape is being changed. We are just moving the triangle. When a figure is translated, reflected, or rotated, the lengths of the sides of the figure do not change. They stay the same. If we're changing the size, then we cannot call that this. Translated, reflected, or rotated will keep the lengths the same. In a triangle, can be translated, rotated, or reflected onto another triangle so that all of the vertices correspond. The triangles are congruent triangles. The parts of congruent triangles that match are called corresponding parts. So the order of the vertices indicates the corresponding parts. Triangle ABC is equal to triangle XYZ with A corresponding to X, B corresponding to Y, and C corresponding to Z. So in the triangle, if A is the vertex at the top, in the new triangle, X will be the vertex because they correspond to each other. B and C are the bases. In the new triangle, Y and Z are the bases because they correspond. The vertices correspond. As in a mapping, the order of the vertices indicates the corresponding parts. So in congruent angles, the angle A equals the angle F. You can see that right here. Angle B equals angle D. There's two lines right here to show us angle B, two lines to show us angle D. Angle C equals angle E. So angle C, we have three lines. The corresponding angle is E. Uh-oh. Here we go. I think I pressed the button again. I can just stop using the pen. Clearly it's not working for me. Are the majority of schools still closed? Next next Monday? Next month? In December? Does that mean they'll be open until like April or May?
You will now be placed into the conference.
Woo. Okay, am I muted still? Hello. Can you hear me? I teach math. And we're not using the pen anymore. That causes too many problems. Hello? Okay. So back to the congruent angles. Angle A equals angle F. Angle A is right here at the top. Angle F right below it. We can see that it has one line, meaning that they are congruent. Angle A to angle F. Angle B is congruent to angle D. It has two lines, showing it's different from angle A. It is different from angle F. It is the same as angle D. And angle C is equal to angle E. They are congruent angles. There are three lines in angle C, and there are three lines in angle E. Also, congruent sides. We showed you when those triangles were moved that the sides also move and stay the same. So side AB, right here, is equal to side FD. It has three lines to show it is equal to the AB. Different from all three other sides, but equal to A and B. Now, side BC is equal to D and E. B and C, the base line, is equal to, congruent with line DE, right here. And lastly, AC is equal to F and E. Now you can see that all of the sides have different numbers of lines through them. That means that they are only congruent with a side that has the same number of lines. So side F and E is only congruent with A and C. Side A and B is only congruent with F and D. And the base of DE is only congruent with BC. That's what these lines mean. The same with the angles. They're showing you what angle they are congruent with. Apparently I drew on this slide. If the corresponding parts of two triangles are congruent, then the two triangles are congruent. If the two triangles are congruent, then the corresponding parts of the two triangles are congruent. So, if we see these two triangles, we see that it has corresponding parts. We can say they are congruent triangles. It's the same way with if we are told that triangle ABC is congruent with triangle FDE, we know that it has congruent parts. So we know that angle C is congruent with angle E. We know angle F is congruent with angle A. And we know angle B is congruent with angle D. Now, in triangle RST equals triangle XYZ, so we know they are congruent. Find the value of n. So we see that angle S equals angle Y. We see that angle S is 50 degrees. And we see angle Y is 2n plus 10. degrees. Because we know they're congruent, we can write this as a formula 50, which is what angle S is, equals 2n plus 10. If they are congruent, then they equal each other. So this angle of angle S equals angle Y. So 50 equals 2n plus 10. You subtract 10 from both sides because you want the n on its own. 40 equals 2n. Divide both sides by 2, and we have n equals 20. When we plug 20 into this n, we have 2 times 20 is 40 plus 10, 50. 50 degrees. Angle S equals angle Y. Now, oh, teacher, in English, please. Uh-oh. Okay, if you have any questions, you may type them in English. That says 555. I don't know what that means. No. I only finished 27 of 41. That. Okay. Somebody said wait a minute. I'm assuming there was a please implied. If anyone has a question, go ahead and type it, and I will stop and answer it. Okay, now we are going into SSS and SAS tests for congruency. Whoa. SSS stands for side, 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 and SAS stands for side, angle, side. What this means is if we know that all three sides are congruent, then we can say it is a congruent triangle. Side, side, side. If all three sides match each other, then it is a congruent triangle. If side AC equals side RT and side AB equals side RS and side BC equals side ST, then triangle ABC equals triangle RST. That is what the side, side, side rule tells us. If three sides of one triangle are congruent to three corresponding sides of another triangle, then the two triangles are congruent. In two triangles, side ZY equals side FE, side XY equals side DE, and side XZ equals side DF. Write a congruent statement for the two triangles. We have a sample answer right below. Because we know all three sides correspond to all three sides of the other triangle, the SSS rule, side, 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 tells us that triangle ZXY equals side FDE. Questions? No? I will continue. In a triangle, the angle formed by two given sides is called the included angle. So angle C is the included angle of side CA and side CB. The two lines are on either side of this angle. So angle C is the included angle. Angle A is the included angle of A and B and A and C. The two lines, the two sides of the triangle on either side of the angle cause this to be the included angle. And we see that angle B is the included angle of side BA and side BC. Using the SSS postulate, you can show that two angles are congruent if their corresponding sides are congruent. You can also show their congruence by using two sides and the included angle. This leads us to the SAS rule, the side angle side rule. If two sides and the included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, then the triangles are congruent. So in the example, we see that side AC equals side RT, and that angle A equals angle R, and that side AB equals side RS. So we see that one side, the included angle, and the other side are all congruent. The side angle side, SAS postulate, tells us that the triangles are congruent. So we can write that triangle ABC equals triangle RST. On a piece of paper, please write your response to the following. Determine whether the triangles are congruent by SAS. If so, write a statement of congruence and tell why they are congruent. If not, explain your reasoning. So are these two triangles congruent by side angle side? If you said no, they are not congruent, or if you saw it, oh, perfect, two of you did. Thank you. They are not congruent because although QP and DF are congruent, and side PR and side FE are congruent, angle P is an included angle, but angle D is not an included angle. Because angle D is not included, they are not congruent. Side angle side does not apply, and they are not congruent triangles. Any questions on section 5.5? Okay. Section 5.6. We will now learn ASA and AAS tests for congruence. Angle side angle and angle angle side. The side of a triangle that falls between two given angles is called the included side of the angles. It is the one side common to both angles. Whoa. I see myself. So side AC is the included side of angle A and angle C. Here's angle A, Here's angle C. Side AC is the included side. Angle C, angle B, side CB is the included side. And side A, side B, AB is the included side. You can show that two triangles are congruent by using two angles and the included side of the triangles. That is angle, side, angle. If two angles and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then the triangles are congruent. So in this example, we see that angle A equals angle R, and that side AC equals side RT, and angle C equals angle T. Then we know that triangle ABC equals triangle RST. We see one angle congruent, we see the included side is congruent, and we see that the other angle is congruent. Thus, angle, side, angle applies, and we know that they are congruent triangles. Now, CA, side CA, and side CB are the non-included sides of angle A and angle B. You can show that two triangles are congruent by using two angles and a non-included side. So if we know that angle A and angle B are congruent, and either side AC or side CB is congruent, then we can say that the triangles are congruent. Here's an example of that. We see that angle A and angle R are congruent. They equal each other. We see that angle C and angle T are congruent, equal each other, and we see that side BC equals side ST. They equal each other. They are congruent. Therefore, we can tell that triangle ABC equals triangle RST. Triangle DEF and triangle LNM have one pair of sides and one pair of angles marked to show congruence. What other pair of angles must be marked so that the two triangles are congruent by angle, angle, side? That was a question. I don't see any answers. Okay, if triangle DEF, this triangle, and triangle LNM have one pair of sides, so say DF and LM, and one pair of angles marked to show congruence, what other pair of angles must be marked so that the triangles are congruent by angle, angle, side? So we see in this example that F and E and M and N are the congruent side. If angle F and angle M are congruent, then FE and MN would be included sides. And for angle, angle, side, we're trying to use the non-included sides. Therefore, D and L are the angles that would need to be marked. If we see that it's angle E and angle N that are congruent, we see that line EF and line NM are congruent. then using angle side, we need to use the angle that does not make MN an included side, which is angle L. So angle D and angle L. Are there any questions? Okay, that's the end of that lesson. Okay. Okay, 10 minutes? Okay, 10-minute break. Last slide, please. Okay. There we go. Why does it say no? No, sir. They don't want to break? Take 10-minute break. Are they saying they don't want to break? Some kids just love math. Oh no, she said let's end. I just don't... It's okay, fractions are easy and fun. Okay. How many students are there? Go, teach.
Like 37.
Oh, wow.
Yeah.
She likes